Hello everyone, welcome to Seeking Cat, and this is a very important DI question. It's from the daily dose of CL, and it actually demonstrates a very important concept which I think is very important whenever you're trying to solve any DI question. So you can pause this video and read the question. I'll directly get to the point. Uh, if I talk about the total students appeared, let's assume that to be TA and total qualified students to be TQ. Now, if we want to, in general, like this is just one question, but specifically in such questions, our aim is to minimize, you know, this difference. Like if it is asked that there was a question just above it where we wanted to minimize the amount of students who have not qualified, right? What will be the least number of students who have not qualified? So in such a scenario, what you have to do is that you have to find a boundary condition. And what boundary condition I'm trying to say is, you'll get it when we create this table. So let's say that this is our table, and total number of students who have appeared in the exam for A will be TA times 12 by 100, right? Similarly, for B it will be 26 by 100. Similarly, for C it will be 24 by 100, and for D 16 by 100, for E 14 by 100, for F it will be 8 by 100. Okay. Similarly, you can complete for Q. I'll be quick with this one. Into obviously TQ. Now you would want that, okay, TA is something, TQ is something, because every entity here, every entity which I have marked here will be an integral value because we are talking about students. So that has to be of type 100k maybe. Well, 100 is a too generic term, right? We want to take it even more further. What all values can we choose for TA? Well, you can find the common factor in all of them, and you will realize that 2 is the only common factor here. So 50k can be the assumed value of TA. Similarly, for TQ, the common factor is 4. So 100 by 4, which is 25k2, can be the assumed value of TQ. Once you reach to this conclusion that TA is 50k kind of a number and TQ is 25k2 type of a number, you need to find the boundary condition. Now the boundary condition will be for the value where TA and TQ are very close by, very close. Now in this situation TA is bigger. In this situation TA is multiplied by a smaller number than TQ, so this can be a potential close situation. This is 16 is greater. This can also be a potential close situation. Here a bigger number is multiplied, so this cannot be a potential and this cannot be a potential. Now if we want that we will check for both of these which is more closer, right? So for C we can write it as 12k minus 10k2. These will be the number of students who have not qualified for A, for C, right? Not qualified. And not qualified students for E will be it will be 7k minus 5k2, right? Now this is an obvious observation that this is taking it more closer, because if you multiply it, it's going to be 4k minus 10k2, right? So this is more closer situation. Okay, so let's erase this fraction. So we are left with this situation. Now in order to make it most close, can we assume that nobody was not qualified in C, right? So if this is the situation, this has to be greater than equal to 0. So let's assume this to be uh, greater than 0, and because we want minimum possible values for k and k2, so let's assume k as 1, and k and k2 have to be integers, and k2 be also 1, right? If this happens, the answer is coming out to be true, and hence ta can be 50 and tq can be 25 in the worst, in the scenario where we want the least possible values. And now if I check the answer, I'm checking the answer, we were asked that what is the least number of students who did not qualify, and the answer was 25, which is correct, because for total number of students, ta minus tq will give me the number of students who did not qualify, which is 25. Now coming back to this question, because this is a extrapolated version of this question, this is the next part of this, that number of qualified students from school D is 10. So let's say that 8 upon 100 into 25k2 is 10, right? So what can we assume? We get that k2 is 5. From this we get 125 to be the value of tq. Great. Okay, so this is given. What is the least number of students from A who did not qualify? Now again going back to A, 12% can be taken common. Ta minus tq, this will give me the value. We want to minimize this value. Again we will go back to our minimum ratio which we were getting. This we were getting for 12k minus 10k2. This has to be greater than equal to 0. Now k2's value is 5, so this will be 50. 12k minus 50 has to be greater than equal to 0. Now for what all values of k will this be satisfied? Well, k can be 4. It will be negative. If k is 5, this is getting satisfied. So k is 5 in the minimal situation. So hence we get 250 as this value, and hence 12 upon 100, 250 minus 125, 125 by 100 into 12, and 5 by 4, 3, 15 will be the answer. So this is a very interesting question. A lot of concepts of DI were used in this question. I really like this question if you want to strengthen this closeness of the distance kind of questions in DI. So I hope you like this video.